Hey everybody, the purpose of this video is to give you a solution to 91622 problem in your collaborative statistics textbook. One of the neat things about this book is the authors had their students actually write some of the problems, and I think this is one of them. It's pretty cute. Talking about a belief about the cost of boxed macaroni and cheese because they like it because it's cheap and it's high in nutritional value. And I thought that was, oh, this is cute. So my favorite and main staple food is mac and cheese. It's high in taste and low in cost and nutritional value. I wonder if they meant to say that, low in nutritional value. It's pretty accurate, actually, but whatever. It's pasta. Pasta's good. So anyway, they have a claim that they think the average cost of a box of macaroni and cheese was at most $1. Now that's an interesting claim. At most $1. Average cost at most $1. Now that to me sounds like mu is less than or equal to, but we'll make it continuous, less than $1, right? At most. It cannot be more. It can be less, but it can't be more. So these folks visited 53 closest grocery stores. No, they didn't. There's no way they did that. But whatever. We'll play their game. And here are the values that they collected, and they want to see if these data show that their claim either holds water or doesn't. Do these indicate an at most $1 price tag? Now, just scanning through them, 35 cents, 25 cents, 75 cents. We got 8, 6, and 15. That's quite a few. I mean, that's roughly half of them. Over half of the stores are below $1. Then you've got these very large stores that are above $1. So I'd like to just let's collect this data in a meaningful way. They gave it to us in a nice frequency distribution way. So we're going to go ahead and utilize this. $2.02. I'm just going to throw the numbers in first. 25 cents a box. $1.29. This doesn't mention sales or anything like that, or quality. You have no idea if you're apples comparing here. Maybe you're looking at different quality levels. I mean, from my college days, I remember the deluxe mac and cheese. When we had a little extra money, we'd buy that stuff, the good stuff. The stuff that you didn't have to mix the cheese. It was already goopily mixed in the packages. Fun stuff. 5 stores. Hopefully you can see what I'm doing here, friends. I'm creating a frequency distribution based on their data. 6 stores at 35, 4 stores at 227, 7 stores at 150, 5 stores at 189, and last but not least, 8 stores at 75. Just a little frequency distribution here. I'm going to take a quick peek at the plots just to see if we're even close to symmetric unimodal data. There's our histogram, L1, L2. I'm going to throw a box plot onto these $2.02 and 227 cent boxes of mac and cheese are making me a little bit nervous, a little teensy bit nervous. Okay, let's go a little zoom stat. All right, there it is. I'm going to clean the window up a little bit. We definitely have a min of 25 cents and a max of 227. I'm going to make it 0 to $2.50 just to round it off, and I'm going to make the scale a quarter. Let's see what that looks like if we do it that way. I'm going to change the Y max a little bit to make things fit better. Okay, decent. A little bit higher maybe. Smidge higher. 40. Let's make that scale more logical. All right, there is our distribution. Fairly skewed, fairly skewed. And I think part of the interesting thing about this problem is we can definitely run a t-test on this. We can. There are no outliers by definition of outlier. There's not too much skew by definition of how the box plot indicates skew. But honestly, I'm going to run it. We're going to run it to run the t-test and do what we want to do. But my opinion would be, I would want to go back and look at this data again. The fact that we've got this clump here and this clump over here might imply to me that we may have 2 different populations. You've got the expensive mac and cheese and the cheap mac and cheese. And it didn't make any mention in the problem of, did we normalize this? Did we go and get the cheapest mac and cheese in all these stores? because that would change the. And this might sound stupid because you're talking about mac and cheese, but this could very easily be talking about anything else, like, for example, different foliage covers for certain trees. If you're looking at trees that are 100 years old versus 40 years old, you might be getting vastly different results when you shouldn't be comparing apples and oranges. Anyway, I bring that up. We can run a t-test on this, and we will. Just wanted to throw that out there and make sure you guys understood the potential of no Introstat textbooks really get into should we run the tests. They give you tests of assumptions, and we pass the assumption test. It looks Bell-ish enough. I mean, if you want to, we can run a normal quantile plot. But, it looks good enough for a t-test, so I'll go ahead and test it. Students' claim was that it was no more than $1, so it might be less. We're going to come on down here and change it to less. We got to make sure we indicate our frequency is an L2 and our data list is an L1. And we're going to go ahead and draw the results of our experiment. There they are. All right, on average, their claim doesn't make any sense because the average of all that stuff is actually above $1, which is indicated by this p-value right here. The p-value being more than 0.5. That guy right there. Let me make this a little bit cleaner. Let me turn off the box plot and the histogram real quick and rerun that test for you. All right. Okay, on average, we got an average cost of more than $1, which we kind of thought we were going to have because we had all these 202s and 129s and 227s. So the idea is the student's claim carries no weight. The average cost is not less than $1. I should say the data indicates that the average cost is not less than $1. So there's absolutely no reason to believe the null hypothesis would be that the average either is equal to $1 or greater than $1. There's no reason not to believe that. So there's your conclusion. Your test statistic is actually positive, meaning it's above the expected average of 1. You could run this as a calculate instead of a draw to get the actual average if you needed numerical values. And here it is right here, $1.03, barely above $1. But honestly, what I'm most concerned about is the data set itself. I mean, I don't want to start messing with this data set because I don't know if the data is okay. I mean, it could very well be that all these data points indicate the exact same brand, the prices of macaroni and cheese, not Kraft, not generic, not whoever else makes mac and cheese, but just macaroni and cheese. So I bring that up because it's very simple to run hypothesis tests, but it's not always the easiest thing to know whether or not you should or not. So I just wanted to bring that out. So hope it helped.